Okay, so this is performing simple linear regression in R. So we're not going to talk much about what that means, but just how to do it. So suppose we have two vectors, or in other words, we have two variables, x and y, and we want to use x to forecast or predict y. And how do you do that in R? So instead of looking around for some data, maybe I'll use this data that I was just using in a previous video. That is, if I look at this one, this is data, and I have a bunch of variables here. So how about if I use regression to forecast one based on another? For example, can I build a regression equation, or can I find a good relationship between, say, horsepower and miles per gallon highway? So let's try that. So the variables are, let's see. So suppose I say y equals miles per gallon highway from Cars 93, and x equals Cars 93 horsepower. Let's see what these look like. Okay, that's y, and x is that. Okay, so yeah, okay. Hopefully they're the same size. I guess we could just check that. Length y and x. Yeah. Okay, so now we can try to predict the miles per gallon from the horsepower. So this is what you do. Now, I have trouble on my keyboard finding this symbol. It must be there somewhere. So I hope you can find it. So this is all you have to do. And let's see it. So that's it. So this is this is the result. In other words, this is just giving me the equation, so to speak. So what I mean by that is the equation is y, I can't run this, but I'll just type it. Y equals, the intercept is 38, I'll just leave it at 38, it's 38 point something, but I'll just say 38 for now, plus negative 0.06, whatever, I'll just leave it like that, x. This is basically the equation, okay, that it's given me. So it's not, so it's saying that if you know x, you put, for example, so x was the horsepower, you put the horsepower into this equation, and this will give you the miles per gallon highway. Okay, so that's the equation. Now, how good is this? We'll wait for the next video to see how good this is. How good is this equation? How accurate is it? Another way you can do this, though, is if you have a data frame like we have, we need a data frame that only has two variables in it, since we're doing it with just two variables. So let me look at cars again. So here's Cars 93 again, and let's just take two variables and make a new data frame. So let's just take, well, I guess I could take the same ones that I just had. So what is that? 1, 2, 3, 4, 5, 6, 7. Did I get that right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I want 8 and 9, 10, 11, 12. 9, 10, 11, 12. Okay, 8 and 12. So maybe this will work. So I'm taking, from Cars 93, I'm taking all the rows and just these two columns. Let's see if that works. Okay, so that seems to work. So now, another way that you could have done the regression, if you have the data in a data frame like this, is you could do this. You can run this. So you don't need to know what y and x are. It's going to take them from here. Now, actually, I think this is going to do the reverse. This is going to be x, and this is going to be y. So it's actually doing just the reverse of what I wanted to do, or what I did before, at least. But anyway, if you switch these around, I guess that would be okay. Then it would work. But okay, let's just try this. So looks like it gave the same thing. Well, I'm not sure if it exactly how it's working. You have to play with it a little bit. It might be reading the y and the x from before. Or you could try switching this thing around and seeing if that works. But basically, this is how you run the linear model. Okay, I just tried this again, and it seems like it's consistently reading from y and x, because actually I tried it. I did this up here. So I changed dfrm1 to a different set of variables, but it's still giving me the same result. So it seems to be ignoring this. So you'll have to check that out yourself.